Hello, my name is Mike Driscoll, and today we will talk about type checking in Python. Type checking or hinting is a newer feature of Python that was added in Python 3.5. You won't find type hinting or checking in Python 2. Type checking or hinting is also known as type annotation. Python does not actually enforce type hints, though. You can change the types at will in Python because of this. However, some integrated development environments, also known as IDEs, such as PyCharm, support type hinting and will highlight typing errors. You can also use a tool like MyPy to check your typing for you. And you could add MyPy or a tool like it to your continuous integration machinery, and it will also check it for you and prevent people from checking in code that is not using the type hinting correctly. Today we're going to cover these many topics. We're going to talk about the pros and cons of type hinting, built-in type hinting or variable annotation, collection type hinting, hinting values that could be none, type hinting functions. We'll talk about when things get complicated with type hinting. We'll talk about classes, decorators, aliasing, and some other type hints. Okay, so first let's talk about the pros and cons of type hinting. The pros. Type hints are a nice way to document your code in addition to docstrings. It can make your code look even easier to follow. Type hints can make IDEs and linters give better feedback and better autocomplete in your code, especially if your code is complex. Adding type hints forces you to think about types, which may help you make good decisions during the design of your applications. So it kind of makes you think about it ahead of time when you're creating new code, which is always a good thing. You should always think about your code before you start writing it. The cons. Type hinting code is more verbose and arguably harder to write because you have to put more effort into it and you have to think about it more. Type hinting adds development time as part of making it harder to write. So it's going to take longer to add the type hints, thus the entire development time will increase. Type hinting can have a minor startup time penalty in code that uses it, especially if you import the typing module. If you have a more modern Python, like Python 3.10, some of that will go away because you don't need the typing module as much. We'll talk about that some more later on in this tutorial. Alright, when should you use type hinting? If you plan on writing short code snippets or one-off scripts, you probably don't need to include the type hints. Beginners don't really need to add type hints when they're learning Python, but if you're going to be working in a team or working on a large code base, it's good to know them as soon as you get the basics of Python down. If you're designing a library for other developers to use, adding type hints is probably a good idea. Large Python projects, in other words, thousands and thousands of lines of code, can benefit from type hinting. I found that if you have a large team with lots of different backgrounds, so some people who know Python really well and some who barely know it at all, type hints can also help because the ones who don't know it at all might be coming from Java or C++, and they'll understand the type hints better because of that background than not having it at all. Some core developers recommend adding type hinting if you're going to write unit tests. I don't know any personally, but I've been told that some really highly recommend that. Okay, let's talk about built-in type hinting and variable annotation as well. So, type hinting can be done with the following built-in types: int, float, bool, string, and bytes. Starting in Python 3.9, you can also type hint using these following built-in types: dict, list, set, frozen set, and tuple. Before that, you had to import from the typing module to be able to use type hinting with these particular built-in types. Python 3.9 also supports the types found in the collections library. For full details, check out PEP 585. These types can also be used in functions and in variable annotation. The concept of variable annotation was added in Python 3.6. Variable annotations allows you to add type hints to variables. So when it first came out in 3.5, you could only add type hints to functions. And fortunately, the Python core development team was like, this really needs to be added as soon as possible to variables, and so it was added in 3.6. Here are some examples of variable annotation. Note that you type x, and then the type annotation. In this case, x does not get initialized. So I think if you try to run code like this, it'll actually say x isn't defined, even though you've added a type hint. This does work in a data class, though. Most of the time, when you're doing variable annotation, you're going to want to set the variable to something. So in this case, we create y, which is a float, and we set it to 1.0. Next, we do z as a bool and set it to false. We set a equal to string and set it to hello type hinting. And finally, we have a dictionary, which contains a string for the key and an integer for the value. And that is reflected in the value that we pass to it. Once again, I want to mention that this is in 3.9 only and above, where you can use dict directly. Otherwise, you'd have to do from typing import dict with a capital D. All right, collection type hinting. A collection is a group of items in Python. Common collections or sequences are list, dict, tuple, and set. Let's look at a few examples. So this is how you do it in older Pythons from like 3.8 and below. From typing import list, this is going to be a list of strings. So we say names, here's our type hint, and then we have one string inside this particular list. Awesome. Here's another example. Here's another example of tuples. From typing import tuple, s is a tuple with an int, float, and a string, which is then reflected in the values that we pass to it. Dictionaries are a little bit different in that you should type hint the key and the value. So here we're type hinting the key, and here's the value. We've already seen an example of that. If you know a collection will have a variable size, you don't know how many items are going to be in your tuple or list, you can add an ellipsis like this. So here we have tuple, int, and we don't know how many ints will be in this tuple, so we just put an ellipsis inside of it. If you're using Python 3.9 or newer, you no longer need to import anything from the typing module to annotate lists, dictionaries, or tuples. Instead, you can just do the following. So here are those three examples again, without importing from typing at all. So we have a list with the strings, here's a dictionary with a string key and an integer value, and then a tuple with an indeterminate number of items in it. Hinting values that could be none. What do you do if the value could initially be none or could be returned as a none? Well, sometimes they need to be none, and it gets set later. But you need to be able to tell Python what the values could be. So for that, you use optional. From typing import optional to make this work. So in this case, result should be a string or none. So to make that type hintable, you say optional, and inside of optional, you put in a list of different options that the result could be. So for this example, we just say string, but it could be a string or an int or a dict, and if it is, then you put those in here in a comma delimited fashion. But my function will return either none or a string. That's basically what this is saying here. Starting in Python 3.10, you can simplify this to string pipe none. This is now you're using the union operator, and you don't need to use that whole optional thing anymore, because now you're uniting string and none together. So result can be either of those. And again, you don't need to use the typing module, which is handy. For more details, check out PEP 604. More examples from PEP 604. I just want to show a more complex example. So here we have list union int string, optional int. Again, because we now are using the union operator here, we can just say int union string, so we don't need to import union anymore. And optional int can now be int union none. And there's another example here where we have union float in string. For the return value, now it's just float union value string. And that just simplifies things a lot. Check out PEP 604 for some other examples. Some of my examples are a little bit cut off here. There we go. So instead of typing union string int, you can do typing list string int string union operator int. Anyway, definitely check it out. I think it's pretty cool. Okay, let's talk about type hinting functions. Type hinting functions is similar to type hinting variables. The main difference is that you can also add the return type to a function, which you just saw in that other example. But let's look at it more closely. Here's an adder function where x and y are both integers, and the return is none because we don't actually say return here. We just print out the values of x plus y. Let's say we want to assign the adder function to a variable. You can do that by importing callable. So from typing then callable, a is now a callable. The callable takes in 2 integers and returns none. And then you assign it to the adder function. So you can see here, that's exactly what we're doing. This inner list here is the list of arguments. This is the return value. And, that's how you define it, how you define a callable type hint. Let's look at one more example where you pass in a more complex arguments. So this function takes in a tuple and an optional. So we have an int. This tuple has strings. Z could be none or float. We default it to none. That's a typo right there. I didn't mean to put that colon there. Just ignore that. In fact, we should probably change that because that won't work. All right. Optional none. I think this thing has a couple of typos in it. But anyway, you get the general idea. If x is not. I think this is wrong too. Some bad code in there. All right. Now it's all correct. That's how you would type into a more complex one. I use black to format this. Black is really helpful for auto-formatting code like this. What to do when things get complicated. Now complicated is like when you have none, or when you have to have a variable that can be multiple types. When that happens, you use the union function or union class from the typing module. If you have Python 3.9 or less, you use union. If you have 3.10, you can use that union operator I was showing earlier. So here we say z can be a string or an int. In Python 3.10, you can just say z string union operator int instead, and that gets rid of that extra import that you don't need anymore if you have 3.10 or above. Okay, let's talk about type hinting with a class. As you might expect, type hinting with classes is pretty much the exact same thing, but if you're passing around instances of a class, then you can type hint by just saying t is an instance of class test, and then you just set it to test, So t now is an instance of the test class. That makes it really obvious what's going on when you're passing things around, and I find this really helpful when I'm working with complex data types or complex custom types. Decorators, though, are a very special beast. They are functions that take in other functions and modify them. That's what a decorator is. And you'll technically learn about them later on in my book, Python 101, if you happen to buy it. Adding type hints to decorators is kind of ugly, though. Let's look at an example. So here we go. From typing, import any, callable, type var, and cast. We have f equals type var, crazy stuff in here. My decorator, it takes in a function, f, which is up here, which is basically an alias, and it returns the f. And then we have cast down here at the bottom. Let's go over this bit by bit. So a type var is a way to specify a custom type. You are creating a custom callable type that can take in any number of arguments and return any. Any being any type, basically. Then you create a decorator and add the new type as a type hint for the first argument as well as the return type. So that's what all this code does right here. Next, and we create the cast function, which is used by MyPy specifically. It's a static code checking utility. It is used to cast a value to the specified type. In this case, you are casting the wrapper function as a type f, which is what we called earlier in the previous code. I cut it out here because it didn't fit on the slide. Okay, you might want to study that code a little bit. It's kind of confusing, but it's also listed in the type hinting documentation, so you can also check there. Or you can go on the MyPy website. I think they also have a good example of decorators and how to type hint them correctly. All right, aliasing. You can create a new name for a type known as an alias. We saw a little bit of this in the previous example. Here we're going to rename list as the list type to vector. So from typing import list, vector equals list int. So now we can say A is a vector type, which is a list of integers. So now vector is equivalent to list integer, and they refer to the same type int. Alien is useful for complex types. So if this was like a list of dictionaries or a list of lists, you might want to do that and give it a special name or an alias. The typing documentation has another good example that I reproduced here. In here we're importing dict and tuple, connection options equals dictionary, address equals tuples, the server equals tuple with an address and a connection options item. So here you can see we kind of built up a complex alias here. This code allows you to nest types inside of other types while still being able to write appropriate type hints, and for the most part it's pretty readable. Other type hints. There are several other type hints that you can use as well. For example, if you have a generic mutable type, you can import mutable mapping to create a custom mutable dictionary. If you use context managers a lot, or you create custom context manager classes, then you'll probably want the context manager type from the typing module. There are a bunch of others in the documentation that you're welcome to read. I can't go over them all because that would make this tutorial much too long. All right, let's wrap up. Today I taught you the pros and cons of type hinting. We looked at variable annotation using built-in types. We talked about collection type hinting values that could be none using the optional keyword. We talked about type hinting functions, what to do when things get complicated, like if a value can be multiple types. We talked about classes, decorators, aliasing, and some other random type hints. I hope you found this tutorial very useful, and if you have any questions, feel free to drop them in the comments.